Alright, let's get started. I have opened Arduino. I have with me ESP32 board and an ultrasonic sensor with a few wires. I have just ensured that the board I have selected is ESP32 dev module and the COM port is COM3. Where did I check this? Press Windows X or in your search bar type device manager, and it's going to open up the device manager where in ports COM and LPT you're going to find Silicon Labs, the USB UART bridge, that is COM3. Okay, so this is where my ESP32 is connected to, so I select COM3 here. Now we are good to go. We are ready to upload the code to our ESP32 board. I'm going to write a sample code for you to get started, and then we're going to go into the ultrasonic sensor. Int LED equal to pin number 2. This is pin number 2 on our ESP32. So I'm going to put my setup code here. This is going to be pin mode LED comma output, and then in void loop I'm gonna make my pin turn on and turn off, digital write LED comma high, and then I give a small delay of 100 milliseconds, and then I copy paste the same code where I'm gonna make this pin low. Alright, and I'm ready to upload the code. So I'm going to save this code as ESP32. Where do I put it? I'm going to create a new folder. ESP32 test. I'm going to create ESP32 blink. Okay, and then I am ready to upload the code. The code gets uploaded. You will see that on the ESP32 board. So once the code is uploaded, you will see that the LED on the ESP32 is blinking rapidly. So that's because of the delay, that is 100 milliseconds. Now I know that the ESP32 board that's connected to the computer and the program that I've written works, right? We'll go ahead and write our new code, file new, which is for ultrasonic sensor. So I'm going to save this code. I'm going to say this is US sensor. Okay, and then I'm going to start writing my program here. So I'll say int trigger equal to pin number 23, int echo equal to pin number 24, and then in void setup I will have to say pin mode, trigger is output, and then pin mode echo is input. Yeah, echo is input, and in void loop I'll have to go ahead and type digital write trigger comma high. So I have to trigger this pin. Okay, and then I would give a small delay microseconds, how much, 10, and then I will bring this to trigger, I would make this low. Now once this is done, my echo pin is something that I'll have to start looking for. So I would say int duration equal to pulse in echo comma high. So this is going to give me the duration for which the echo pin is going to be high, that is equal to the duration taken by the pulse or the ultrasonic wave to go hit the obstacle and come back. And with this I would want to do a understanding, I want to see what is I want to see this value in my serial monitor. So I'm going to create a serial.begin. I'm going to call the serial function. I will say serial.println. Whatever I want to print is the duration, and I would give a delay of say 500 milliseconds, so that I am able to see the value of duration. Now I can go ahead and upload this code, but before that I also have to make the pin connections. So I'll save this code and make the pin connections. So the VCC and ground on your ultrasonic sensor, you will be connecting them to VIN on the ultrasonic sensor and ground pin that is right next to the ultrasonic sensor. Okay, now we have the other two pins, which is echo and trigger. So I'll have to make similar connections. The trigger pin needs to be connected to pin number 23. Where is pin number 23? And echo pin is supposed to be connected to pin number 24, but I don't have a pin number 24 here, so I'm going to connect it to pin number 22 and 23. So let's make the changes in the code as well. Okay, I've made the connection to pin number 22 and 23, so I'm going to change in the code as well. Now we are ready to upload the code. Once the code is compiled, you'll see that the code gets uploaded to the ESP32 board. This is my ultrasonic sensor, and on the serial monitor select the right baud rate, and you'll see there is a value that comes in that basically is giving you the value of distance, and as and when I bring my hand closer to the sensor, you'll see that the duration reduces. Right, so let's use this duration and calculate the distance. So for this I will be using the speed of sound formula. So I know the speed of sound in air is equal to 334 meter per second. So what I will be doing is I will be converting this in such a way that I get the value of distance. Okay, so let's do some calculations. Distance is equal to speed multiplied by time, right? and here distance is equal to speed of sound is 334. It's meters, so I need it in centimeters, so I'm going to add 2 zeros. 334 meter per second. But I know that the duration is in microseconds. I'm going to change this to microseconds. 1 followed by 6 zeros. Okay, so this effectively comes down to multiplying this again with time, that is duration. Alright, okay, so this distance is equal to 334 divided by 10,000 multiplied by duration. Okay, this is what I need, and I'm gonna use that in the formula to calculate int. So let me put it as float, because it's going to be a decimal formula. Float distance is equal to 334.00 by 10,000.00 multiplied by duration, that is already calculated, and then let me print serial.println distance. Okay, there's going to be a 500 millisecond delay, and I don't want to print the duration, so I'm gonna highlight, make it a comment line and upload the code. Now that the code is uploaded, I'm going to open the serial monitor to check for distance. I am getting some distance. The moment I bring my hand over the sensor, the distance is varying. It is reducing as in when I'm bringing my hand closer to the sensor, and changing as in when I'm moving away from the sensor. But this distance is equal to 2 times the actual distance between the obstacle, because it calculates the time taken by the sensor, by the ultrasonic wave to go from the sensor and come back. So it's a two-way distance. So I need the actual distance. So I'm going to calculate the actual distance. So act distance is equal to distance by 2. And I have to, so this is also going to be a float. So we'll print act distance and then upload the code. I'm going to get the actual distance in my serial monitor. So this is the code for ultrasonic sensor. When you want to connect an ultrasonic sensor to an ESP32 and measure the distance, this is how you do it. So you get some value. The moment I bring my hand closer to the sensor, you'll see that the distance is changing. Okay, as and when I bring my hand closer to the sensor, you see the distance is varying, it's changing. And as and when I move away from the sensor, the distance is going to be different. Now this distance is actually the distance between the camera and the sensor. And as and when I bring the sensor closer to the camera, you'll see that the distance is reducing. Okay, this is distance that you're seeing here, that you're measuring, is approximately 1 centimeter accurate. So what you get is not a very accurate value, but it's sufficient for us to use it for a robot. If you have any questions, you can reach out to us at reachus@justabotics.in. Let us know how you've So that's it for today in terms of connecting your ultrasonic sensor to the ESP32 board.